All right, so section 2.2 is about dealing with errors. Here are our learning objectives from the book and the course. So let's talk about two types of errors. There's random errors and there's systematic errors. Random errors occur because of random and inherently unpredictable events when we're taking our measurements. Systematic errors occur when there's a problem in the measurement system that affects all measurements in the same way. So for example, I used to work in a chemistry lab and I used to have to send my rulers out to make sure that they were actually exactly a foot and had them like approved to make sure that all my measurements were exact. You know, if my ruler had been a little bit too short, then systematically I would have been making all those errors. Fun fact. So if we are trying to take the weight of a baby and he's wiggling about, I said he because of the blue diaper, but it could be any gender identity. Okay, so he's wiggling about. It's hard for us to take his measurements. That's random. That's unpredictable. That's a random error that we could not overcome. Whereas this scale with nothing on it is off, right? It's even though it should say 0, it says 100, it says 1.2 pounds or ounces, or how do they measure kids? I don't know. This would be a systematic error. I have way too much fun talking to myself and making these videos. You have no idea. So that's a systematic error. Boy. So we can calculate sizes of error. We've got absolute versus relative error. Absolute error describes how far a claimed or measured value lies from the true value. Absolute error is the measured value minus the true value. Relative error compares the size of the absolute error to the true value, and it's often expressed as a percentage. So we could have relative error as a percent is going to be the absolute error, which we already found was the claimed or measured value minus the true value, divided by the true value times 100, and that makes it a percentage. So let's find the absolute and relative error. So your true weight is 150 pounds, but a scale says you weigh 155 pounds. Your absolute error is going to be your measured value minus the true value. So that's going to be 155 was the weight that was measured, minus 150, which is the true value. So you have an absolute error of 5 pounds. In order to calculate the relative error, you take the absolute error over the true value times 100. And this is going to be expressed as a percent. So we found our absolute error already to be 5 pounds. So I take 5 over 150 times, that was my true value, times 100. And that's going to give me 3.3 repeating percent. So that's how we'd calculate the absolute error and the relative error. So when we're describing our results, we can talk about accuracy and we can talk about precision. Accuracy describes how closely a measurement approximates a true value. An accurate measurement is really, really close to the true value. Precision describes the amount of detail in the measurement. So like, for instance, how many decimal places you can successfully go to. That'd be very precise. So suppose your true weight is 102.4 pounds. The scale at the doctor's office, which can only read to the nearest quarter pound, says that you weigh 102.25 pounds. The scale at the gym, which gives you a digital readout to the nearest 0.1 pound, says you weigh 100.7 pounds. Which is more precise and which is more accurate? Remember, precise is the most detailed, and accuracy is the closest to the true value. I can already see that 102.25 is closest to the true value. And we might think, okay, this is also the most precise because a quarter is 0.25 if we wrote it as a decimal, okay? But that's not the case because I could only have 102, 102.25, 102.75, or 103. I can't go to the tenths decimal place. This is 1/4. If I go to the 0.1 pound, that's 1/10. So that means that the scale at the gym is more precise, but the scale at the doctor's office is more accurate.